Hi, this is Matt Baker. Welcome to episode 2 in my series on the evolutionary tree of life. Last time we started at the very bottom of the chart with Luca, the last universal common ancestor. We then proceeded to look at some of the earliest forms of life, bacteria and archaea, which eventually came together to form the very first eukaryote cells. From there, we followed the branch leading to the animal kingdom, which then split into protostomes and deuterostomes. Protostomes include arthropods like insects and spiders, both of which share the same basic body plan, only with special modifications. In contrast, deuterostomes include animals with internal skeletons, the earliest of which were fish. Most fish today have ray fins, but there are still a few that have lobe fins. And it is with these lobe-finned fish that we're going to start today's video, proceeding from there to discuss amphibians, reptiles, including dinosaurs, and then finally the only remaining dinosaurs on Earth today, birds. But before we begin, I want to once again point out that if you want to get a copy of the chart I'm using in this series, you can do so by going to usefulcharts.com or by clicking the link in the description or pinned comment. It's available in both a standard poster size as well as a jumbo size. Okay, so the first thing we need to discuss is how a creature like this eventually evolved into a creature like this. Both have skulls and a central backbone, so that's not the issue. The issue is how a fish's fins, which are used for swimming, evolved into a land animal's limbs, which are used for walking. Well, like I said last time, it has to do with a special category of fish called Sarcopterygi, which still exists to this day, but are quite a bit different from the dominant Actinopterygi class. You see, most fish have ray fins that look like this. They're basically just one strong bone with a bunch of really thin bones attached to it, forming a sort of fan that flaps back and forth. In contrast, Sarcopterygi fish have fins that look like this. They too have a bunch of thin bones, albeit a bit thicker, but what's really interesting are these three bones here. If you were to look at an X-ray of your own arm, you'd see that the upper part, between your shoulder and elbow, has a single bone, which is called the humerus, whereas the lower part between your elbow and your hand has two bones, called the radius and ulna. After that, you get all the small bones in your wrist, hand, and fingers. Well, this basic structure can be found in just about every four-limbed animal on Earth, whether it's a lizard or a lion. Even birds have it, as well as bats and whales. That's because all four-limbed animals are the descendants of Sarcopterygi fish. But how did some fish go from having fin rays to having lobe rays? Well, it may be easier than you think. If you've ever had a home aquarium, you might be familiar with zebrafish. They're often used in scientific research, and nowadays you can buy a genetically modified version called glowfish, which glows in the dark. But just a few years ago, in 2021, scientists were able to genetically modify a zebrafish in another interesting way. By creating a mutation in just one gene called HOXA11, they were able to breed zebrafish with two new fin bones, similar to the radius and ulna. However, stronger limbs were not the only thing that were needed in order to make the transition from water to land possible. There was also the issue of breathing. As you probably know, most fish breathe using gills, which are organs behind the eyes used to extract oxygen from water. Well, it might surprise you to learn that lungs actually evolved around the same time as gills. In other words, the earliest fish had both. However, most fish ended up relying entirely on their gills, which then allowed their lung to evolve into the swim bladder, which they could then use to control their buoyancy. But notice that I said most fish. One of the surviving members of the Sarcopterygi branch is the lungfish, which, as its name implies, uses lungs to breathe. But even if some fish had lungs as well as stronger limbs, what led them to leave the water and crawl onto land? Well, it wasn't a sudden move like most cartoons suggest. Like most things in evolution, it took millions of years. First of all, it's important to remember that vertebrates were not the first animals to leave the water. Insects beat them onto the land by tens of millions of years, and plants and fungi were there even earlier. Which is good because once the vertebrates arrived, they needed something to eat. And eating is one explanation for why some fish eventually ventured into shallow water, and then into shallower water, and then even more shallower water, and so forth. You see, one of the great things about shallow water, from a fish's perspective, is that it has less predators. So once there were ample insects to eat there, why wouldn't a fish move into that neighborhood? Now, I've taken a little longer to explain this part of the tree because it's often the part that some people find hard to accept. In the past, creationists liked to talk a lot about missing links and how no one had ever found a fish with feet. Well, that's no longer an argument they use because in recent decades, we've actually found fossils that look exactly like a half-fish, half-lizard-like creature. The most famous of these is Tiktaalik, discovered in 2004. Living around 370 million years ago, it had scales and gills, like a fish, but also a flat head and strong downward-facing limbs, like a lizard. Note in particular that it had 4 limbs. This is important because every single vertebrate after this point also only has 4 limbs, which is why they are called tetrapods. The earliest tetrapods, such as Ichthyostega, would have been amphibious, meaning that they could live both in water and on land. Some tetrapods still can, and these are placed in the amphibian class, the two most well-known groups being salamanders and frogs. Take note that a toad is just a special type of frog, with drier skin and shorter back legs. All non-amphibian tetrapods are amniotes. This is because they evolved to have an extra layer that surrounds their embryos, forming what's called the amniotic sac. Evolving around 320 million years ago, this served to better protect the embryo, and hence it allowed certain tetrapods to lay eggs on land instead of in the water, like frogs and salamanders still do. The end result was that amniotes were able to venture further and further away from the water. At this point, tetrapods split in 2 very different directions. We get the synapsid line, which eventually led to mammals, and the sauropsid line, which leads to reptiles and birds. For the rest of this video, we are going to focus exclusively on the sauropsids, returning to the synapsids in episode 3. First of all, take note that the word sauropsid literally means lizard face, even though not all reptiles are actually lizards. Lizards are actually just one type of reptile, but because they are the most common type around today, people sometimes use the two terms interchangeably. All lizards, such as geckos, dragon lizards, chameleons, and iguanas, belong to the Squamata order, as do snakes. Snakes are included because they actually evolved from earlier lizards that went on to lose their legs. Another major reptile order that still exists today is the Testudines order, which includes turtles and tortoises. The difference between a turtle and a tortoise is kind of the same as the difference between a frog and a toad. Turtles live in more wet environments, whereas tortoises are just a special type of turtle that live in more dry environments. Finally, in terms of major extant reptiles, there's the crocodile order, which also includes alligators. The easiest way to tell the difference between a crocodile and an alligator is to look at their nose, although you obviously don't want to get too close. Crocodiles have a more pointy nose, like a V, whereas alligators have a more roundy nose, like a U. Note that crocodiles belong to a subgroup of reptiles called archosaurs, which means that they are more closely related to dinosaurs than either lizards or turtles. Now, before I move on to talk about dinosaurs, let me point out 3 orders that are often associated with dinosaurs, but were not actually true dinosaurs in the technical sense. These include pterosaurs, such as pterodactyls, which most people tend to think of as flying dinosaurs, as well as ichthyosaurs and plesiosaurs, which most people think of as swimming dinosaurs. Note that ichthyosaurs looked more like dolphins, whereas plesiosaurs looked more like the supposed Loch Ness monster. Actual dinosaurs are only those reptiles that belong to the Dinosauria clade, which evolved from early archosaurs. As you might know, the word dinosaur literally means terrible lizard. It was coined in 1842, around the same time that the very first partial dinosaur skeletons were found and preserved. Now, humans around the world had been finding individual dinosaur bones for centuries before this, but it wasn't until the mid-1800s that geologists started to realize that they belonged to an extinct form of large reptiles. Prior to this, it was assumed that they must have belonged to giant humans or dragons. Nowadays, we know that dinosaurs lived approximately 240 years ago and can be divided into two main categories: Ornithischia, meaning bird-hipped, and Saurischia, meaning reptile-hipped. This is somewhat confusing because birds eventually evolved from Saurischia. Anyhow, Ornithischian dinosaurs were mostly plant-eating, and they include well-known genera like Ankylosaurus, Parasaurolophus, Stegosaurus, and Triceratops. In contrast, Saurischian dinosaurs include both plant eaters, called sauropods, as well as carnivores, called theropods. Sauropods, like the familiar Brontosaurus, are those really big dinosaurs with long necks. In fact, they were the largest animals to ever walk the earth. However, it's the theropods, such as Tyrannosaurus rex, that we tend to consider to be the mightiest of all the dinosaurs. Which is interesting because it's from the theropod dinosaurs that birds descend. The path to birds starts with aviale, which simply means bird wings. This clade includes Archaeopteryx, which is the earliest known dinosaur to have feathers and wings. Remember, pterodactyls are not true dinosaurs, and their line died out. Archaeopteryx is therefore also considered to have been the first bird, even though technically it does not belong to the aves or bird class. Now, this is where I have to point out an anomaly on this chart. As I mentioned last time, living things are still classified using the old Linnaean naming system, which works like this. Inside a kingdom are many phyla. Inside a phylum are many classes. Inside a class are many orders, and so on. There's never supposed to be a phylum within a phylum, or a class inside a class. But in this case, we do have a class within a class. We have the Aves class nested inside the reptile class. This is because when Linnaeus made the original system, he didn't know that birds were descended from reptiles. He thought they were a totally separate category, and therefore he classified them as such. But we now know that birds definitely descend from reptiles, from dinosaurs to be exact. So does this mean that birds are dinosaurs? Well, technically speaking, yes. Although in common usage, we tend to reserve the word dinosaur exclusively for the now extinct non-avian dinosaurs. Birds are also technically reptiles. But again, in common usage, we tend to use the word reptile only for non-avian reptiles. Because of this change in understanding, some taxonomists want to stop calling aves a class and simply consider it a general clade instead. I've opted to keep it as a class because I think generally people still tend to think of birds as being distinct from other reptiles, which is why they end up being a class inside a class. Okay, when it comes to birds, the oldest type, cladistically speaking, are ostriches and the related emus and kiwis. Ostriches cannot fly, but evolved from earlier birds that could. Next comes fowl, which can be divided into waterfowl, like ducks, and landfowl, like chickens. Some fowl, like geese, are very good at flying, while others, like chickens, can fly only a little bit. Of course, one of the most important things about fowl is that they are a major food source for humans, not only in terms of their meat, but also their eggs. All the remaining birds fall under the category of neo-aves, or new birds. To explain their origin, I first need to introduce you to some of the terms used for measuring time in the deep past, which I've largely avoided up to this point. In episode 1, I mentioned the Cambrian explosion, which is so named because it occurred at the beginning of the Cambrian period, the first of 12 time periods that cover the last 540 million years, give or take a million. Now, take note that the starting date of 540 million years ago was chosen not because that's when life began, but rather because that's when life started to go in a bunch of different directions, as evidenced by the fossil record. So, after the Cambrian comes the Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous, Paleogene, Neogene, and Quaternary. Now, throughout the history of life on Earth, there have been 5 major extinction events caused by either asteroid impacts or volcanic eruptions, or some other huge catastrophe. In each case, these events caused the majority of species living on the planet to die out completely. However, this in turn helped drive evolution because the species that did survive could suddenly take advantage of a dramatically new situation. So what we find is that following each one of these major extinction events, we get what was once a small branch of the tree suddenly going in a bunch of new directions. So for example, after this one here, that's when we suddenly got lots of different types of insects and bony fish. And this one here, well, that's around the time that the first land vertebrates started to really thrive. But then came this one, the PT extinction. It's named that because it marks the transition between the Permian and Triassic periods. Well, it was the biggest mass extinction event of all time, killing off about 80% of all ocean species and about 70% of all land species. In fact, the PT extinction changed things so much that we use it to mark the transition to a whole new era. We call the first 6 periods the Paleozoic era. Paleozoic meaning old life. Whereas we call the next 3 periods the Mesozoic era, meaning middle life. The Paleozoic is also sometimes referred to as the age of fish, because the greatest diversity of life during this entire era could be found in the ocean. Whereas the Mesozoic is referred to as the age of reptiles, because that's when the dinosaurs dominated. Although true dinosaurs didn't actually appear until the Jurassic, after yet another major extinction event. Which brings us to the final mass extinction, and the one that you're likely the most familiar with. Most people know it as the KT extinction, K standing for Cretaceous and T standing for Tertiary, which was an older term used for the Paleogene and Neogene. We know that this one was definitely caused by an asteroid, and we even know exactly where it hit. It's right here in Mexico. But the reason most people know about it is that this was the event that killed off the dinosaurs, paving the way for mammals to dominate. That's why the current era, the Cenozoic, which means recent life, is also called the Age of Mammals. However, that's a bit misleading because it could also just as accurately be called the Age of Birds, which is the reason why I took the time to explain all of this. You see, it was right after the KT event and the extinction of the dinosaurs that the neo-aves really took off. Or to put it another way, it was after the KT event that the non-avian dinosaurs were replaced by the avian dinosaurs. Okay, so let's now take a look at the neo-aves. First off, there's the seabirds, which include herons and pelicans, but also penguins. And then there's the shorebirds, which includes seagulls and their relatives. The word columbia comes from the Latin columba, which means a pigeon or dove. So that's why these birds are in the Columbiformes order. Take note that there's no real difference between a pigeon and a dove, besides the fact that we tend to use the word dove for the smaller species in this group. The word apodiformes literally means footless, even though birds in this order, such as hummingbirds, do actually have feet. It's just that they have rather small feet, so small that they can't even use them to walk or jump. All other neo-aves fall into the land birds category, which could more accurately be called the tree birds category because the defining feature of this group is that they mostly live in trees. From here, things split into the Afroaves, which originally evolved in what is now Africa, and the Australaves, which originally evolved in Australia and South America. Afroaves includes woodpeckers, most birds of prey like eagles and hawks, as well as owls, whereas Australaves includes parrots and the largest bird order of all, the passerines, or perching birds. Passerines are well known to most people because they include all of the songbirds, many of whom live alongside humans in our neighborhoods as well as in the forest. These include popular backyard birds like sparrows, cardinals, finches, chickadees, starlings, and robins. But it also includes a family of birds that ranks among the most intelligent animals in the world, corvids. Corvids include magpies and jays, as well as crows and ravens. The main difference between a crow and a raven is that a raven is much larger and goes, whereas a crow is smaller and goes. Okay, that brings us to the end of episode 2. Next time, we'll go back to synapsids and trace that line to mammals, and we'll cover all the various mammal branches, including the one that led to humans. If you haven't yet got a copy of this poster and want to do so, be sure to visit usefulcharts.com or simply click the link in the description or pinned comment. Thanks for watching.